Continuing with the section 3.3-3.5, A, we have now the last topic in here is the how to find the rational zeros of polynomials if they exist. So there is a rational zeros theorem which says that if p of x is a polynomial with integer coefficients, I hope everyone knows integers means the coefficients are could be 0, plus minus 1, plus minus 2, plus minus 3, and so on, not any fractions, so or decimals, right? So integers, coefficients, and then and p over q is a rational zero of p of x. And if there is a number like 2, 3, or 3 over 5, or just negative 3 over 4, or negative 5, or positive 2, things like that. Because remember, rational numbers are the numbers which are can be written as a fraction. So all the integers are also rational numbers. Why? Because if you have an integer, you can always put a 1 under it, and that becomes a rational number. So it says that so if we have this polynomial with integer coefficients, and say p over q is a rational zero of the function polynomial, then p is a factor of the constant term of the polynomial, and q is the factor of the leading coefficient of the polynomial. What do we mean? The constant term, in general, we write our polynomial like this: polynomial of degree n. So a sub n x sub to the n plus a n minus 1 x to the n minus 1 plus dot 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 plus a 1 x plus a sub 0. So this is the constant term, and so if you want, you can use the a sub 0 for wherever you have mentioned the constant term, and this will be the lead coefficient a sub n. So here an example is use the rational zeros theorem to list all the possible rational zeros of the given polynomial. So this is how we do it. You can first write what is a constant term here. Write it over here. 8, and the lead coefficient so the leading coefficient is 1. Now what are the factors or the divisors of 8? So the p is all possible. Okay, let's call like this: all possible p values. Okay, or possible values of p. So you can write any word, or you can just put here p colon. So it will be all the factors of 8. What divides 8? Well, we know 2 and 4 divide 8, but what other numbers divide 8? 8 divides 8, and 1 divides every number. So 1 is always going to be there. So we have 1, 2, 4, and 8. But what we do here, we also take the positive negative. So we put positive negative 1 plus minus 1 plus minus 2 plus minus 4 and plus minus 8. So these are the factors of 8. And what are the possible values for q? Just plus minus 1. Now to find the possible rational zeros, we have to find p over q. So what are the possible values for p over q? So every p value, we have to divide it by the every q value. In this case, we have only plus minus 1 for the q. So we get plus minus 1 over plus minus 1, comma, plus minus, you can see that this is going to be same, like, and it is going to be the same as the values of p in this case, because division is only by 1, plus or minus 1. So I can directly say that the values are going to be plus minus 1, plus minus 2, plus minus 4, plus minus 8. The next one, here my a, so instead of constant term I can write it, a sub 0 is 8, a sub n is 6, sorry, a sub 0 is 12, and a sub n is 6. So what are the value p values? P are the factors of or divisors of 12, which are 1, 2, 3, 4, 6, and 12. But we write them as plus minus 1, plus minus 2, plus minus 3, plus minus 4, and then plus minus 6, and then plus minus 12. What about q? This will be the factors of 6, which are plus minus 1, plus minus 2, plus minus 3, and then plus minus 6. So now for p over q, the possible values of p over q will be, so now we have to take all these values for p and then divide them with the values of q. And if any number is repeated, we won't rewrite it. So the first, when I divide by plus minus 1, we know that we are going to get the values of p. So let me write those first. Plus minus 1, plus minus 2, plus minus 3, minus 4, plus minus 6, plus minus 12. Okay. This is when I divided the values by 1. Then next will be that we divide all the values of p by plus minus 2. So now I am going to take this and divide all the values above it. So it will become, so when I divide 1, so I get plus minus 1 over plus minus 2, comma, plus minus 2 over plus minus 2. Well, what is this? This is just plus minus 1, which is already present here. So we will not rewrite it. Okay, we go to the next value. So what is the next value? Or what will be the next value? Plus minus 3 over plus minus 2. This is a new value. Then plus minus 4 over plus minus 2, which will give us what? Plus minus 4 over plus minus 2 will give us plus minus 2, which is already present here. So we will not rewrite that value. So then next will be plus minus 6 over plus minus 2. What does that give you? Plus minus 6 over plus minus 2. Well, 2 goes into 6 3 times. So this is going to give you plus minus 3, which means we don't write it because it's already written. It's already in the set. So we do not write this. So the next will be plus minus 12 over plus minus 2, which will give us 6. So again, that is something we already have. so we don't write it. So then we go to the 3. So now we are going to divide by 3 all the p values one by one. The first one will be plus minus 1 over plus minus 3. Second will be plus minus 2 over plus minus 3. Do we have that before? No. So we'll put that plus minus 2 over plus minus 3. What about the next one? That will be plus minus 3 over plus minus 3, which is plus minus 1, so we don't write that. Next will be plus minus 4 over plus minus 3. We don't have that, so we will put it in the okay. The next will be plus minus 6 over plus minus 3, which is going to give us plus minus 2, which is in the list, so we don't write that. Then next will be plus minus 12 over plus minus 3, which is going to give us plus minus 4, and that is also in the list already, so we will not write that. Now the last thing we have to do is divide all the values by of p by plus minus 6. So I'll change the color here. Okay, let's see if this works. Light green. So if I will have plus minus 1 over plus minus 6, we don't have that, so we will put it in the list. Plus minus, okay, this is not good, so I think we will continue with, maybe I'll use it. So we have plus minus 1 over plus minus 6, comma, plus minus 2 over plus minus 6, plus that will give me 1 over 3. Do I have that? Yes. You see, we have it over here. So that we will not write that plus minus 2 over plus minus 6. Now plus minus 3 over plus minus 6. 3 over 6 is 1 over 2. So we already have it, so we will not write that. Then plus minus 4 over plus minus 6. So plus minus 4 over plus minus 6. But 4 over 6 is 2 over 3. And we have that over here. So we will not write this one. And then plus minus 6 over plus minus 6 is plus minus 1, so that is not added. Then plus minus 12 over plus minus 6 is plus minus 2, which is already there. So these are all possible values of the rational zero of this polynomial. So you see, as we have more, we have this leading coefficient and the constant terms, the bigger the number they are, or the more factors they have, the more number of possibilities appear. Okay, so this was 3.3-3.5a completed, so you should be able to do the homeworks related to this.